Hey devs, welcome to this comprehensive video on authentication and authorization. In the past project of this channel, I used third-party services like Clerk to handle Auth. And don't get me wrong, those tools are amazing and make things super easy. But I think it's also crucial to understand how Auth actually works under the hood. That's why I'm making this a two-part mini-series. In this first video, we're diving into Auth theory. We'll tackle topics like what's the difference between authentication and authorization, when should you use one over the other, and how they actually work under the hood. Then in the next video, we'll build a full authentication system from scratch using Typesript, Node.js, Express, and so on. In this video, we'll cover sessions, JWTs, refresh tokens, Auth, 2FA, everything. So, if you have always wanted to really understand Auth, this is the series for you. Let's get into it. First thing first, authentication means who are you, and authorization means what you're allowed to do. Authentication is about verifying who you are, confirming your identity. When you log in into a website, you're authenticating yourself. Authorization, on the other hand, is about determining what you can access, basically your permissions in the system. Once the system knows who you are, it can decide what resources you're allowed to use. Think of it like this. Authentication is like showing your ID card at the entrance of a building, while authorization is determining which rooms of that building you can enter once you're inside. So any modern system needs to identify users, verify credentials, and restrict or allow access based on roles or permissions. Let's explore the main authentication methods used in modern web application. The first one is session-based authentication. This is one of the oldest methods still used, especially in monolithic server-rendered applications. Here's how it works. User logs in with his credentials, then the server verifies this credential against the DB. If credentials are valid, the server creates a session and stores session data in a DB or a cache like Redis. In the meantime, the server generates a unique session ID for this session and sends it back to the user browser, usually stored in a secure cookie. On every next request, the browser automatically sends the cookie back to the server. The server checks the session ID and knows who the user is, then the client can see the requested resource. This method is easy to implement and session data is stored server-side, not exposing sensitive data into the browser. On the other hand, it's not ideal for mobile apps or APIs, and it doesn't scale well because the server must store session data for every active user. This can become a bottleneck and consume significant server resources, especially with many users. Now, let's talk about a more modern approach, especially popular with APIs, microservices, and single-page application: token-based authentication, often using JSON Web Tokens, JWT. The key idea here is to be stateless. The server doesn't need to keep track of logged-in users in its own storage after the initial login. That's how it works. User logs in with his credentials. The server verifies this credential against the DB. But wait, before moving on, let's talk about how do we store passwords safely in the first place. Before creating a token, we must make sure user passwords are securely stored. Never store passwords in plain text. We always use hashing. Hashing is a one-way process of securing plain text by creating a bit of a fixed size called hash using cryptographic hash function. So, during registration, the user sends his password. The server hashes it using a library like bcrypt, then the hashed password is stored in the database. So, during the login, the user submits email and password. The server retrieves the hashed password from the DB, it hashes the incoming password and compares the two. If they match, the login is successful. This prevents anyone from reading user passwords, even if the database is compromised. Hashing is often combined with salting, which adds randomness to make the hashes even more secure. Let's get back to our flow. If credentials are valid, the server generates a JWT. This isn't just a random ID, it's a token carrying some information. A JWT is formed by three parts: header, payload, and signature. The header contains info about the token and the sign-in algorithm used. The payload contains claims, basically information about the user like user ID, email, maybe roles, but never sensitive data, and token metadata like expiration. Then we have the last part, the signature, that is created using a secret key only the server knows. Then the server sends this JWT back to the client stores this token, typically in local storage, and on each request, the client sends the token in the authorization header. Think of HTTP header as metadata that are attached to every request to provide additional information. And at the end, the server receives the request, extracts the token, and verifies the signature using its secret key. If the signature is valid and the token hasn't expired, the server trusts the information in the payload and knows who the user is, without needing to look up a session. This method is stateless. The server doesn't need to store session data, improving scalability and reducing server load. Great for microservices and distributed systems. One of the cons, they might be security concerns if this method is not implemented correctly, and also the token size. In fact, including lots of data in the payload can make the token very large, increasing request overhead. Another limitation of JWTs is that they should typically have a short lifetime for security reasons, usually minutes or hours, but we don't want user to log in again every hour. This is where refresh tokens comes in, creating a two-token system. First of all, when a user logs in, they receive two tokens. An access token may be valid for 15-60 minutes, and a refresh token may be valid for, 7 days. The access token is used for all API requests until it expires. Once expired, instead of asking the user to log in again, the client uses the refresh token to request a new access token. The server validates the refresh token and creates a new access token. So with this method, the user stays logged in without needing to re-enter credentials. This pattern is called token rotation and is definitely a best practice for JWT authentication. Then we have the last method, OAuth 2.0. This one is often confused with authentication, but it's different. OAuth is an authorization framework, not an authentication protocol. It's about delegation. Think about logging with Google or logging with Facebook. You aren't actually giving that website your Google password, right? You're telling Google or Facebook, hey, it's okay to let this application access some of my information or perform certain action on my behalf. That's how it works. The user clicks login with Google. The app redirects to Google's consent screen. User authenticates with the provider, in this case Google. Google redirects the user back to the client with an authorization code. The application exchanges this code for access and refresh tokens. The application uses this token to access resources. The pros here are there is no need to store passwords and you trust big providers like Google or GitHub, and also the onboarding is very smooth. The cons here are just that the setup of OAuth 2.0 is more complex and you depend on third-party APIs. A quick mention to 2FA. No matter which authentication method you use, you can enhance security with 2FA. The principle is simple but powerful. Authentication can be based on something you know, so the password, something you have, like phone number, email access, hardware key, or something you are, like biometrics, like fingerprint or face. 2FA requires at least two of these factors. How it works? After the user enters their correct password, the system asks for a second factor, a temporary code, a code generated by Google Authenticator, or a biometric check like a fingerprint or Face ID. Of course, this is a recommended best practice because it adds an extra layer of security even if the password is compromised. Alright, now that we know who the user is, thanks to authentication, next step is figuring out what they're allowed to do. And as we already saw, that's where authorization comes in. A common way to manage authorization is through RBAC or role-based access control. This system assigns roles to users like user, editor, admin, and defines what action each role can perform. Let's break it down with an example. Imagine you're building a blogging platform. A user with the role user can only read articles. An editor can create or update posts, and an admin can delete anything and manage users. Rather than checking permissions manually for every user, we assign a role when the user is created, typically when they register, and store it in the database. Later, when the user logs in, we include the role inside the JWT payload, so every time they make a request to a protected route, the backend extracts the JWT from the authorization header, verifies the token, reads the role from the payload, and decides if the user has permission to perform that action. Let's say someone tries to delete a post. The backend checks if the role is admin. If it's not, the server responds with something like 403 forbidden. RBAC is powerful because it simplifies permission management, keeps your codebase clean, and gives you full control over what each role can and cannot do. Alright, we covered a lot today, but in part 2 we're going to build a complete authentication system from scratch. So if you're ready to implement what we just learned, hit the like button, subscribe, and see you in the next one.